Welcome to another edition of Screencast-O-Matic 2017. I'm Mr. Runyan 2.0. Just having some fun. Sorry. Math time. Let's get to do this today. So we're going to do a little different. I'm actually going to try to teach the whole lesson from the beginning instead of just straight from the application problem. So Module 3, Lesson 11. What are we going to be able to do? We are going to be able to subtract fractions, making like units numerically. So we were just doing addition, so now we're going to do subtraction. Okay, so let's look at mental fluency. So it's part minus to fractions and mixed numbers. So let's take out the first one. So I'm going to say a subtraction sentence, and I want you to think in your head. You don't have to say it or talk. The subtraction sentence with the answer. Right? So 1 minus 1/2 is a half, right? When you say 1/2, it looks like this. It's 1/2, okay? 2 minus 1/2, 1.5. 3 minus 1/2, 2.5. 7 minus 1.5, 6.5. Now let's look at 1 minus 1/3. That would be 2/3, right? Yeah. 1 minus 2/3 would be 1/3. 2 minus 2/3 would be 1 and 1/3. 2 minus 1/3 would be 1 and 2/3. 2 minus 1/3 would be 1 and 2/3. 5 minus 1/4. 4 and 3/4. And 5 minus 3/4 would be 4 and 1/4. Excellent job. Okay, let's take some fluency practice. Add and subtracting fractions with like units. So they're. I'm going to say a subtraction sentence, and I want you to say the answer. So 3/7 add 1/7 is 4/7. 7 minus 1/7 is 2/7. Yawn, yawn, yawn. 3/7 minus 1/7 is 2/7. 3/7 add 3/7 is 6/7. 3/7 subtract 3/7 is 0. And finally, 4/7 add 3/7. 7/7. Can't get any easier than that, can it? Okay, so now I'm going to show you an addition sentence, and I want you to say true or false. If it's false, say the sum that makes the addition sentence true. Got it? So 2/5 add 2/5 equals 4/10. True or false? The answer is true. Right? Or is it false? Well, let's look at it. So we have 5 and 5. Well, equals 4/10. What? We don't add the denominator, so we're going to say that it's false. I would say that 2/5 add 2/5 would be 4/5. Silly duck. 5/8 add 3/8 equals 1. I would say it's true. Whew. Yawn meisters. And finally, 5/6 add 1/6 equals 6/12. That would be true. False. The denominators are the same already, so it would just be 6, 6, which would equal 1. Okay, now we're to our application problem. And this is actually pretty easy. So Meredith went to the movies. She spent 2/5 of her money on a ticket and 3/7 of her money on popcorn. How much money did she spend? And you can also figure out how much money is left. Pause the video, please, and solve the problem. Go. Oh, you're stuck? Or you got them right? So you're ready for the answer? Alright, let's do this. So if we did pictures like this, let's get a different color. My favorite. So 2/5, right? Or 3/7. Just like that. And if we use this pictorially, now we're going to do the opposite, right? We're going to combine it. So we're going to do 1, 2, 3, 4, and that should give us 1, 2, 3, 4, 5. And then we're going to do 7 this way. 1, 2, 3, 4, 5, 6. And it doesn't have to be pretty, does it? 1, 2, 3, 4, 5, 6, 7. Okay. Now all we have to do is add, well, I know that the area of this is going to be a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So what would a 5 by 7 equal? Well, our denominator should equal 35. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 colored on the first one. And we're going to add it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 35ths. Okay, and a quicker way to do that again would be to do the area model, but I just wanted to count for you. So we could have just done a 5 by 3. So now our answer is 29 35ths. Okay, so how much money is left? Well, she has 6 35ths left. Let's see if we're close. Oops. Yeah. So they actually drew a picture on this one. Okay. And then add 14 35ths, 15 35ths, 29 35ths, and how much money does she have left? Well, that's easy. You just, what's remaining? 30, 31, 32, 33, 34, 35, 6. Good job. Let's move on. Okay, so concept development. So we have 1/3 minus 1/5. Some of you are like, Mr. Runyan, this is just so easy. You sound like my 5-year-old. Alright, let's keep going. So let's look at this. You don't really have a partner, but I want you to think to yourself, what's one way that you could go about solving this? Okay, let's keep going. What is a like unit for thirds and fifths? So we're thinking about one way that we could have solved it. So we're going to think about what a like unit is. And I know the Mr. Runyan trick is that we grab the big number, right? And we're going to find multiples. So 5, 3 can't go into 5, 10, right? 3 can't go into 10, so we do another multiple, 15. 3 goes into 15. So I would say 15 would work. 30 would work. So there are some like units. Since we know how to find like units for addition using an equation, let's use that knowledge to subtract using an equation instead of a picture. So really all we're going to do is pretty much do some of the same stuff that we have been doing, except we're going to be subtracting. Okay, so here we go. So we have our problem, 1/3 minus 1/5. How many 15ths are equal to 1/3? How many 15ths? 5, right? So if we took it, and we're going to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 1/3, there's one group, two groups, three groups, and in 1 out of 3 would be 5, and there are 15 total. So this here is 15 in the equivalency. So we're going to do that because we're just basically multiplying. You do it times what you do on the bottom, you do on the top. So you end up with 5 15ths subtract 3 15ths. So there are 5 times as many selected units. 5 times as many units in the whole. All this fun jazz. How many 15ths are equal to 1/5? How many 15ths are equal to 1/5? Do you know? Well, again, we're looking at 1/5. How many 15ths? We're looking for 5. So really, we could, I wonder if I can just take this, throw it this way. Okay, so now we have groups of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is still 15, but now we have them in groups of 5s. 1, 2, 3, 4, 5, and they are in groups of 5, but there are 3 in each one. So there would be 3. 3 times as many of the selected units. So let's move on. Let's try to practice this one. Okay, this is a pretty end, so we should be able just to move right through. So now we have 5 minus. What do we need to multiply by to make 3/5 into smaller units? So you're saying right now, you're like, Mr. Runyan, this is a pretty small unit right now. It's not a whole. Yeah, but we can make it smaller, right? And by smaller, I mean you take that slice of pizza like this, okay? And normally, all pizzas are split up into 8 like that, but you could make it into smaller pieces just like that. So that's what it means by smaller units. Get rid of that green. We want some purple. So what do we multiply to make 1/6 into smaller units? Well, again, we're going to look to some fifths, right? Excuse me. Okay, and then we end up multiplying our denominators, and what you do on the bottom, you do on the top, and you end up with 18/30ths, subtract 5/30ths, and then you subtract, and you get 13/30ths. Alright, so now we're getting to a little bit of harder stuff versus just kind of some really boring stuff that I feel like we've done a pretty good job on. So problem number 3. So what are some different ways we can solve this problem? Think about it. Okay, what ways could we solve this problem? Let's look at what number 1 has. So one method, we could, I like this one, decomposing. We've done it a few times. So we could make this 5/5 and 3/4. That makes sense because we're going to make these equal, right? So you might as well make this whole the same as 3/5. Well, then you'd end up with 2/5 and 3/4. And why are we doing that? Because if you look at it here, what are we doing? We are subtracting, right? So if we're going to take 3/5 away, and if we have a whole already, can't we make this 5/5 and then just take 3/5 away from the 5/5? So we're decomposing this, and we're making it easier to solve. I love it. And we have 2/5 add 3/4 now, because now you got to put this back together, and now you have to do common denominators, and you end up with an answer of 1 3/20. Okay, another way we could have done it, we could have just flat out taken the 1 out. We've worked with that, and then we make our denominators the same, and then we add our 1 back in, and we get 1 3/20. And finally, the third way we could do it is just by composing. We're going to make the mixed number into an improper fraction. So we're going to take that 1, which is really 4/4, and add it to the 3. So now you're going to end up with 7/4 like we have here. And we have 7/4 minus 3/5. Well, you've got to make those denominators the same. So then you're going to end up with 35/20 and 12/20. And when you subtract, you end up with 23/20. And again, 1 3/20. So there are 3 very different ways. You're more than welcome to grab your math journal and copy these in if you wanted to, and whichever one helps you. To me personally, I kind of like the second one in the middle, but the third one also is pretty easy. But you do have a bigger multiplication problem usually. Okay, another problem. So we have problem number 4. 3/5 subtract 2 1/2. What are some different ways that we can solve this problem? So think about what we just did. Try to solve it. So pause and solve. It looks like there are, excuse me, 3 different methods, and there's some number line methods. So pause. Go. Okay, so you're good. So one way that we did it, again, we could have taken that 3 out, and we'd have 3 3/5, and then we would take the 2 1/2 away from that, and you're left with 1/2. Add 3/5, and then make your denominators the same, and then you add, and you end up with 1 1/10. Okay. Method number 2. Go ahead and just subtract the whole, so you do what is already similar, and the whole is a whole no matter where it's at or what it looks like, right? So 3 minus 2 is 1, and then you're left with 3/5 minus 1/2. Well, now again, you do the denominators, make them equal, and you're left with 1 1/10. Again, this is probably the easiest one to me. And then finally, method 3. So we're going to take that 3. We know that that 3 is 3 sets of 5/5. So 5, 10, 15. We're going to take it, add the 15 to the 3, and you'd have 18/5. And the reason why it's 3 3/5 is because you can't have 18/5 because it's 18, and that's way more than 5. It's like clowns. You can only get 5 clowns in a car, but 18 show up. So you have to have 3 clowns, cars, and 3/5 of another one. So really, you're going to have 4 clown cars. And then you're going to subtract. But again, you have to make sure your denominators are still always the same. Let's take a look at some of the number line methods. So we could have started it from 0, obviously. Okay, and then we're going to create an add. And then we're going to subtract 3 minus 2 minus 1/2. So 3 minus 2 minus 1/2. And then you're going to add that 1/2 plus 3/5 back. So it's going to show you all of the different ways. Okay, so let's move on. Okay, so what I'd like you to do here, you don't have to do number line. Really, I mean, for math, is if you're comfortable doing a number line, I just want you to get the right answer. So 5 3/4 minus 3 1/6. I would like you to solve it. Go. Did you not pause it yet? Make sure you pause it, please. Okay, So did you estimate the answer first? Okay. So do you think that the answer is going to be closer to 2 or 2.5? Okay. And maybe you've already solved it. So if we look at it and we do it on the number line, okay, so we start with 5 3/4. We're going to take away 1, 2, 3, because that's right here, take away 3, and then we're going to take away 1/6. Okay. Pretty crazy. Alright, so we are on the problem sets. I pretty much think you guys should be fraction ninjas, so I'm not really going to show you a lot of work. And just because I'm not there, I still need you to make sure that you're working super duper hard and actually work at all these. And you have to do homework before we get on anything else today. So at this time, if you pause, and you can go ahead if you want and just do maybe A, B, C, and D. And then I will put answers, and then you can do E, F, G, and H, and then I will put more answers on. That way you can check yourself and you're making sure you did them right. Okay, so please pause the video. Go. Did you pause it so you're done? Okay. Time lapse. Okay, so we have some answers. So a half minus 1/3 would be 1/6, and the common denominator between these obviously would be a 6. B, 7/10 minus 1/3, the common denominator is 30, and once you subtract them, you get 11/30. C, the answer is 1/8, and D, the answer is 1 1/40. Again, I've done a lot of work on the last videos on trying to help you solve your problem sets. I want to be able to have you do the work and now see the answers. So if you're not getting all 4 of these, you probably need to start watching some of the older videos again. Okay, so at this time, I'd like you to solve E, F, G, and you can skip H since it's on the number line. Go. Time lapse. Okay, so here are your answers for E, F, and G. 1 2/15. F is 1 2/15. And G is 3 4/21. Alright, let's get into my favorite stuff, the word problems. So George says that to subtract fractions with different denominators, you always have to multiply the denominators to find the common unit. For example, 3/8 minus 1/6 equals 18/48 minus 8/48. Can you show George by doing the work to show him that a chosen denominator could have been lower than 48, and then solve? Go. Pause. Okay, so you could have gotten probably 24s, because if you've taken 8, next multiple 16, 6 doesn't go. 24, 6 goes into 24. 6 goes into 24 4 times, and 8 times 3 is 24. So make sure you multiply this by 3, and well, that was back here. 3 times 3 is 9, and you end up with 5/24. Let's look at 3. Melling has 1 1/4 liter of orange juice. She drinks 1/3 of it. How much orange juice does she have left? Okay, pretty easy. And for extra hard work, you could always do this extension. Say, pause and go. Thank you. Okay, so I'm going to do the method of we have 1 1/4, and we're taking away 1/3 because this is what she has, and she drinks this. Well, I'm going to take this, and I'm going to create it into 3/3. Okay, because 3/3 equals 1. Well, 3/3 minus 1/3 is 2/3. 2/3 add 1/4. Okay, and that equals, well, you gotta make these equal. 3. So this would be 3. This would be 8. So you'd have 11 twelfths. And there you go. Okay. Another way that you could have done that, maybe you wanted just to do it the normal way. So 1 and 1/4 minus 1/3. Okay. So we're going to make these common. And you do that by multiplying. And what you do on the bottom, you do on the top. Okay, and you end up with 1 and 3/12. Subtract 4/12. Oh, Mr. Runyan, you can't take 4 away from 3. Okay, so we have to borrow from here. And in this fraction, we have 12/12. Okay, well, we can take 3 away from that, right? And then we don't have any left. And we only have 1 left here. So now we need to take 1 away from this. Oops, 29. Mr. Runyan's writing crazy things on here. 12ths. Okay, and you take that last one right here, 1. So 12/12 minus 1/12. And you end up with 11/12. Okay, let's look at number 4, last one, and then you have 10 problems on your homework to work on, please. So Harlan used 3.5 kilograms of sand to make a large hourglass. To make a smaller hourglass, he only used 1 3/7 kilograms of sand. How much more sand did it take to make the large hourglass than the smaller one? Okay, pause the video and solve. Good job. Okay, so it says that for the large one he used 3.5, and for a small one he used 1 3/7. Well, how much more did he use to make the large hourglass? So we're going to subtract 3.5, and we're going to take away 1 3/7. Okay, so again, there's a few ways you could do this. We can do our wholes, or maybe we'll just take them out. So 3 minus 1 is 2, right? And now we have 2. I'm going to change my color for you. And now we need to make sure these are common denominators. And I know that it's going to be 14. So I'm just going to do those by 7, by 2. So you end up with 7/14. Take away 6/14, which would be 2 and 1/14. Got it? So you should be finished with everything now. So if you can go ahead, 2 and 1/14, look at that, 11/12. Liter for the other extension, 1/4 liter. So other than that, right now you need to follow the subs directions and work on homework, and then you're good to go. Thank you.